Okay, let's take a look at the quadratic formula in a little bit more depth. So here we have a problem asking us to solve the following equation using the quadratic formula. So we have 2x squared minus 5x plus 4 equals 0. And I have the quadratic formula over on the side. So what I need to do is identify my a, my b, and my c, just like normal. So if we just take, I'm going to go through this very quickly, because it's not really the solution that we want from this, it's part of the quadratic formula. What information does it give us? So here, I'll substitute this into my formula, and I work it out, and when I do this, if I'm typing it in my calculator, I'm getting an error. And I'm getting an error again on both of them, so I have an error. So take a quick look and think, why is this producing an error if I was to put it into my calculator? Well, if you notice, it's that square root. This square root is very important. Now I have a negative value and I can't square root the negative. So, what does this mean for the graph? Now that is the question. So this is called the discriminant, okay? So the b squared minus 4ac underneath that square root is our discriminant. So let's break this down to more steps. We already realized we cannot square root a negative number. So essentially, this means we cannot work out a value where this crosses the x-axis and gives us solutions. So that's what this is telling us. So what that actually means on a graph is there'd be no real roots, but we'll get to that picture in a moment. So the discriminant is a part of the quadratic formula which tells you whether an equation is solvable or not. It can also tell you how many roots and whether you can factorize or not. And thirdly, it also tells you the nature of the roots. So every quadratic equation has 2 roots, 1 root, or 0 roots, okay, in the real plane. So meaning where it crosses the axes, we'd have 2, 1, or it won't cross at all. Now, this discriminant will tell us all of this information, so it's very powerful. So if we look at this example here, so the discriminant is not the whole quadratic equation, it is just the b squared minus 4ac. That's the important piece, right there. So if this value underneath the square root, if it's greater than 0, this tells me I have 2 real distinct roots. It means I have 2 solutions. So my graph is going to cross the axes at 2 points, giving me 2 solutions. If our discriminant, our b squared minus 4ac, is equal to 0, this tells me I have 2 real roots, but it's 1 repeated root. So it means that it will cross the axes once. Okay, it only crosses or touches the axes once. So it looks like one solution. Now if I was to look at b squared minus 4ac is less than 0, now this is what we had in our first example. So if it's less than 0, then we know there's going to be no solution, so there are no real roots. And that means it's not going to cross the axes at all. So it's not crossing my axes. So here, the discriminant is telling us the nature of the roots. So if it's greater than 0, the nature of the roots, there's 2 real distinct ones. If it's equal to 0, there are 2 real equal roots or 1 repeated root. And if it's less than 0, the nature of the roots, well, there are no real roots. So let's look at an example. Here, you may wish to pause the video and give this question a try. So we want to state the nature of the roots. So we have x squared plus x plus 9 equals 0. So I don't want to solve, I don't want to know what x is, I just want to know the nature. So I'm going to identify my a, my b, and my c. And I'm going to substitute it into my discriminant, which is just b squared minus 4ac. So when I substitute this in, I have 1 squared minus 4 times 1 times 9, And I work this out, and I'm going to get negative 35. So going back to my question at the top, the nature of the roots, well, b squared minus 4ac is less than 0. I got a negative number, so less than 0. Therefore, there are no real roots. This sentence and this statement is important because that is actually telling me the nature of the roots. This answer is just helping me identify it. And this sentence is answering this form of question. Let's try another one. Pause the video and give it a try. Okay, so now we want to know what is the discriminant and state the nature of the roots. This is just another way to write the same type of question. So identify my a, b, and my c, substitute those values into b squared minus 4ac, and when I work it out, I'm going to get 0. So here my discriminant is 0, and the nature of my roots, b squared minus 4ac is equal to 0, therefore there are 2 equal roots. So that is how you use the discriminant to find the nature of the roots. Now, another piece of information that we talked about was that discriminant. It helps us identify whether we can factorize this quadratic or not. So when a, b, and c are integers, so positive or negative numbers, whole numbers, right, the solutions to ax squared plus bx plus c equals 0 are rational numbers if and only if b squared minus 4ac is a perfect square. So you can factorize the quadratic. So what this means in other words, in straightforward words, if you can square root the discriminant, you can factorize the equation. That's what this says, okay? So if it's a perfect square and I can square root that value underneath the square root, so if I can square root the discriminant, then I can factorize. So let's look at a quick example just to finish off. So here I want to know, can I factorize this? So 2x squared plus 5x plus 2 equals 0. So can I factorize this? Well, let's check with the discriminant. So I'm going to substitute my values in. I want to work it out. I get 9. So the question is, can I square root 9? So can I factorize? Well, I square root 9 and I get 3. So yes, I can factorize. And then you'll see over on the side, this can factorize. So this discriminant is very powerful and you get a lot of information from it.